Hey everyone, thanks for tuning in. I'm Chris Potts. This is a practice run of a talk I'm giving on Sunday at the NeurIPS CogInterp workshop. My title is Reassessing Stimulus Poverty Arguments Using Causal Interpretability Methods. I am going to shine a light on the interp methods here, but you could also think of this talk as a meditation on the rich, interconnected nature of linguistic evidence. To start, let me offer you a high-level statement of the poverty of the stimulus argument. This one comes from the book The Logical Problem of Language Acquisition. In their introduction to the book, Hornstein and Lightfoot write, "People attain knowledge of the structure of their language for which no evidence is available in the data to which they are exposed as children." And then sometime later, Lightfoot wrote, "The linguistic literature is full of arguments of this type, arguments from the poverty of the stimulus." So 2 notes about these quotations. First, I'm going to change no evidence to insufficient evidence. I think no evidence would be an incredibly high bar to surpass. And the second is that I grant that the linguistic literature is full of arguments for the poverty of the stimulus, but not that it is full of successful arguments to that effect. And indeed, I think it's going to be very difficult to establish these arguments. I'm open-minded about this, but it's a very difficult sort of thing to successfully argue for. Before diving into the details, let me just offer my argument in a nutshell here. There are really just 2 claims I want to make. The first is that large language models learn to represent deep, abstract connections between different words and constructions. It follows from this that infrequent phenomena could receive positive support from more frequent phenomena. For the first claim, I'm going to use the causal interp methods that I mentioned before, and a striking finding of that work is that we learn that large language models are inducing features, dependencies, constituent structure, many of the core constructs of linguistic theory. I find this tremendously validating. It's a new kind of evidence for things that linguists have long posited in their analyses of language. It is an interesting twist in this context that all of this stuff is emerging as a side effect of purely data-driven imitative learning. We could set that aside for now, although I do think it's relevant. The more important thing is the second conclusion there, because it shows that we are going to have a very difficult time establishing that there was actually insufficient evidence for something, given that other more frequent phenomena could be contributing indirect positive evidence to that apparently sparse phenomenon. And let me give you a sense impressionistically for how this argument works with an example I'm going to return to for the end of the talk. So on the center of the slide here, I have the English sentence, "What the child wanted was chocolate." And this involves an English construction that's called the pseudo-cleft. It's a filler gap construction, and it's a fairly rare construction in the sense that it hardly ever occurs in corpora and is probably therefore pretty sparse in our own experience, to the point where you might wonder how we manage to acquire robust knowledge of the construction at all. But that mystery is largely solved if we grant the premise that you can recruit information from much more frequent related constructions, like the embedded question, "We know what the child wanted," or "What did the child want?" a matrix question, or even restrictive relative clauses like "the chocolate which the child wanted." If the filler gap aspect of these constructions can be brought to bear on the task of learning the pseudo-cleft, it's less mysterious that we master the pseudo-cleft because in fact there was an abundance of indirect evidence for how it should be constructed. And this argument is quite general. My target example here involves a predicational construction. Maybe we can recruit information from incredibly frequent things like "it was chocolate." And that's not even to mention the kind of whole substrate of concepts like constituency, variable binding, wordhood, agreement. If we're sensitive to all of these abstract things as learners, and they're kind of pervasively in evidence across our experience, we can bring them to bear on the task of learning infrequent things, and suddenly those infrequent things look robustly supported by the available evidence. Now, I am by no means the first to make this argument. A classic entry in the literature is this paper, Lewis and Ellman from 2001, called "A Connectionist Investigation of Linguistic Arguments from the Poverty of the Stimulus, Learning the Unlearnable." And at the heart of this paper is really a methodological lesson. They write, The result demonstrates that before a property of language can reasonably be supposed not to have been learned, that is to be innate or have an innate source, it is necessary to give greater consideration to the indirect positive evidence in the data, and connectionism can be invaluable to linguists in that respect. They are observing that neural networks, connectionist networks, are incredibly powerful learners that will be very sensitive to all the sources of indirect positive evidence and therefore make us alive to the fact that the evidence might be richer than we might have anticipated. I am basically just cheering on this argument, and my own modest contribution beyond evidence from newer language models is to introduce causal interpretability as a toolkit for us really richly characterizing the nature of this indirect positive evidence. And I'm pleased to report that Lewis and Ellman, I think, kicked off a trend in the literature. Here are a couple of newer papers that use different models of the learner, but come to the same conclusion about the richness of linguistic evidence. And here are some newer papers that I think have internalized those previous lessons and are now, as a result, offering much more sophisticated and interesting stimulus poverty arguments than we saw before, in virtue of the fact that they really are thinking deeply about the interconnected nature of linguistic evidence. Now, before getting to the causal interp stuff, I want to take a moment to just fully state the stimulus poverty argument and also give you a sense for how these arguments have unfolded in the linguistic literature, because I think that's really illuminating about how things have played out. To start, I'll just state the core stimulus poverty argument, and I'm going to do this in two versions that I think are actually the same argument, but one sounds controversial and the other seems obviously true. Let me start with the controversial one. So we start with the assumption that there are three potential mechanisms for language acquisition: data-driven learning, direct instruction, and innate mechanisms. Then we observe, I think truly, that there is not enough direct instruction to account for all the knowledge that children have of their language. There's not enough classroom instruction, lessons from caregivers. None of that can fully account for the final state of children when it comes to the languages that they speak. So we can reject that as a complete account of language acquisition. Then we get the premise that sounds controversial. Children learn things for which there is insufficient evidence in their experience. And of course, it follows from that that human language learning involves some innate mechanisms. That sounds controversial. Let me give you a version that I think really can't be controversial. Children have a finite set of experiences with language, of whatever kind, direct instruction, whatever it is. These experiences are consistent with a large set of potential learning targets T. Now that is simply the problem of induction. Any finite set of experiences is going to be consistent with an infinitude of potential hypotheses about those experiences. So the fact that children systematically arrive at a specific target alpha that's a member of that large hypothesis space does truly show that children have inductive biases favoring alpha, but this argument also shows that we have pervasively in our cognitive lives stimulus poverty arguments, not just for language. I think what this really shows is that the controversies around stimulus poverty arguments are actually to do with the nature of these innate mechanisms or inductive biases. And in particular, you have a kind of general expectation in the linguistic literature that these specific innate mechanisms or inductive biases will be highly specific to language and also highly contingent in some sense. That is where all of the debates and all the controversy lies, and it's that kind of thing that I think is so difficult to establish. Now, to give you a sense for how these arguments tend to unfold in the literature, I think it's good to have a specific example in mind. So I've chosen the case of English subject-verb agreement. So we have examples like the man in the room is. And a noteworthy thing about this example is that it doesn't disambiguate between two appealing seeming hypotheses. One is that agreement is controlled by the head noun man in this case, and the other that it's controlled by the nearest noun, in this case room. Both of them are singular, so they would lead to the same verb as the outcome. But examples like the man in the rooms is immediately disambiguate in favor of the hypothesis that agreement is controlled by the head of the construction, in this case man. And that plays out through the entire paradigm. Consistently, we have evidence that it is not the nearest noun that determines agreement, but rather the head noun of the construction. So now what we want to do is use this to build what could be a stimulus poverty argument. I'll point out that the crucial disambiguating evidence between the two hypotheses, head noun and nearest noun, are given in the box here. And let's suppose that our target child has lots of experiences with language, but those experiences don't include overtly the disambiguating examples. And then the question is, if the child still achieves the outcome of assuming agreement is with the head noun, how do they do it given that they were lacking what seems to be the crucial evidence? Now, I think ideally we would construct these arguments as follows. We have our finite set of experiences with language, and we feed those into our target learner, in this case, this human baby. And we observe that this baby comes to the conclusion that the correct hypothesis is alpha, agreeing with the head noun. Implicit in this is an assumption that there are other learners, L1 and say L2, that given that same set of experiences would come to different conclusions about the nature of the data. And that's why we would end up ascribing to the baby some innate learning mechanisms that steered it toward alpha, and those would presumably be lacking or different in the learners L1 and L2. Now remember, we are trying to understand the nature of this learner and its inductive biases, but we have lots of other moving pieces here. In particular, it is just very hard even to measure the set of linguistic experiences that this learner has, to say nothing of truly estimating the information content of that set of experiences. And that's kind of where the focus of this talk lies. We also, of course, have the full burden of figuring out exactly the state of knowledge for this learner, and that involves all the complexity of doing linguistic analysis. But I think the chief obstacle to these arguments in the linguistic literature has been a kind of pervasive reluctance to rely on artificial learners. We need L1 and L2 in here to create the relevant counterfactuals, and if you think it through, we actually need to replace our human baby with some abstract learner L0 that's minimally different from L1 and L2 in order to triangulate on the causal factors that lead to these different outcomes. But that is almost never done in the linguistic literature. What happens instead is a kind of attempt at a shortcut. And the shortcut works like this. I have my finite set of linguistic experiences, but then I simply posit that there are two or more reasonable conclusions one could make about that finite set of experiences. And then I observe that the human baby arrives at one of them and conclude that that human baby must have an inductive bias. And the implication is an inductive bias that is specific to this hypothesis alpha. Here it could be something about headedness. Now, the critical assumption here is that we have a kind of idea that these hypotheses seem consistent with the input set of experiences. We haven't specified the learner. We're just saying seems consistent. And this is always going to be dicey until we finally specify the nature of the learner. But the idea is that in general for learners, they crucially need the examples that are in the gray box there in order to unambiguously end up at the conclusion alpha using just data-driven learning mechanisms. And since they achieve that without the examples in the gray box, they must have an inductive bias specifically in favor of that outcome. But we just don't know what else is in this green circle here, this set of experiences. And there could be lots of things steering a learner toward alpha that don't have anything in particular to do with headedness, for example. And so I posit that if a domain general data-driven learner favors alpha as well, that should at least give us pause about the nature of the argument, right? The idea is I have this finite set of experiences and these outcomes, and I observe what the baby does, but then if I introduce, say, a large language model, expose it to the same set of experiences, and it too is steered toward the hypothesis alpha, well then, I think it's revealed to us that the evidence was in some sense more discriminating than we might have thought. And what this really means is that now we have to center our stimulus poverty argument around the nature of the particular learner that we care about. And we are in a very challenging analytical situation here because we now have two learners that, given the same finite set of experiences, have the same inductive bias in the sense that they have the same outcome. But we're trying to establish that the human learner has some specific inductive bias that the language model lacks, even though we know that mechanism is not strictly speaking necessary in the broadest sense. And that's what I mean by this having to appeal to very direct properties of the human learner for the argument to go through. I just think that's going to be very difficult. I am open-minded, but it sounds analytically very challenging. Now, as I said, I think the role of causal interpretability here is to give us a very rich picture of the nature of the indirect evidence that might be available to a learner in a kind of in-principle sense. So I want to introduce this toolkit very briefly. I'm going to do that by way of some specific examples and build up to some evidence for rich interconnections across different constructions. But to start, I'll just give you a sense for the methods. And to do that, I'm going to use Syntax Gym, a nice benchmark for focused evaluation of language models against linguistic behaviors, and our extension of it that we called Causal Gym, that is more about evaluating causal interp methods. As before, for my running example, I'm going to use English subject-verb agreement. Syntax Gym and Causal Gym make a condition for that kind of example available to us, and we could do a kind of targeted behavioral evaluation that would go like this. I have my language model here, and it processes the example, the man in the room. And I observe that for its next token prediction, it has a preference for is over are. When I have that same language model process the plural counterpart, the men in the room, I observe that the model now has a bias in favor of are over is for its next token prediction. And that looks like a bit of behavioral evidence that the model also has a theory of agreement that is based in the head noun rather than the nearest distractor noun, room in this case. And with Syntax Gym, we can quantify that a bit, and we find that even modestly powerful large language models are really good at this task. So on the right here, I have a bunch of Pythia models evaluated against a bunch of different Syntax Gym conditions for agreement. That's all those lines there with the average given as the dark black line. And you can see that even the smallest of the Pythia models are quite successful at this agreement task, and the largest of the models essentially fully solve it. And this is really promising as evidence that they too have a theory of headedness. But what are the mechanisms? I don't think that just based on this behavioral data, we can actually make a mechanistic conclusion about how they're solving and thinking about the problem of headedness. And that's where the causal interp methods come in. So I'm going to do this in a kind of hypothesis-driven way. On the slide here, I've got a very simple linguistic theory of agreement that basically just says the number feature on the head noun of the subject needs to agree with the corresponding number feature on the verb that will be inflected. And I want to test that hypothesis in language models. So I again have my language model process the example, the man in the room. And I have the same language model process the example, the men in the room. And I observe for that case that it has a preference for are over is. Now I'm going to hypothesize that the number feature for the subject head noun is encoded in that particular representation in the language model. And to test that hypothesis, I'm going to take that representation and put it in the corresponding place in the model as it processes the plural example, the men in the room. And if that intervention causes that hybrid version of the language model to switch its preference from are to is, then I have one piece of evidence that indeed that representation was a kind of modular encoding of information that includes my target number feature. And if I can do that for lots of examples, I'll have built up a really strong argument that indeed somewhere in that representation is a kind of encoding of the relevant feature. And the striking thing about modern language models is that that kind of intervention is very successful. Here I'm offering you some examples from the Pythia 2.8 billion parameter model. This is a heat map, and what I've essentially done for the visualizations is just turn the model on its side. But I'm reporting the same kind of intervention that I showed you before. And each spot in the heat map corresponds to a representation in the language model, and the darker that rectangle is, the more intervention success we had at that site when it comes to, for example, doing an intervention that actually causes the model to change its preference for the number agreement on the next token prediction for the verb. And what you see here is lots of modular encoding of this feature in exactly the way that you might expect given the linguistic theory that I stated. We have the feature encoded above the head noun, and also richly encoded at the point that it needs to make a prediction that would, in some sense, include that feature. So that looks wonderfully validating about the idea that at an abstract level, the model is tracking this number feature in a way that aligns with expectations from linguistic theory. I want to show you one more example to build to the kind of rich, positive, indirect evidence that I was talking about before. This next example involves filler gap constructions. And this is drawing heavily on this paper from Wilcox et al. In Linguistic Inquiry. So we can do the same kind of behavioral testing that I described before. Here I have the example, I know that the lion devoured, and I can check the next token prediction. Since devour is an obligatorily transitive verb, the model has a strong preference for something that would be consistent with a continuation for a direct object, like devoured the gazelle, and a dispreference for things like yesterday, a kind of adverb there. In the minimally different example that involves a filler gap construction, I know what the lion devoured. Now the direct object position is filled by the WH word what, and now the model has a preference in the reverse direction. It expects an adverb more than it expects another direct object. That's the behavioral testing. Models are good in that sense, and now we can do the kind of causal interp thing that I described before. We have the language model process this example. We have the same language model process the filler gap case, and now if I can take a representation from the case without a filler gap construction and put it in the corresponding case in the filler gap case and have that flip the preference of the model so that it now in effect thinks it is processing a regular embedded question with no filler gap, then I have evidence that indeed that representation that I target includes a modular encoding of the filler gap feature itself. And again, a striking thing about modern language models is that they do a lot of encoding of exactly that type of feature. Here I have a plot again from Pythia, 2.8 billion parameters. It's a single clause case. My friend reported that or what the uncle forged. Here on the right here I have a multi-clause case. We all know that or what the delivery boy stated that the pilot described. And you have a lot of modular encoding of relevant features. Of course, you get a strong effect on the filler because that kind of defines these two constructions. You also get some intermediate tracking of the gap site across potential places in the multi-clause example where it could be discharged. And maybe most intriguing of all, you get some evidence of local tracking of this filler gap dependency through filler words in the examples. And many linguistic theories posit that these long-distance filler gap constructions in fact consist of a bunch of very local dependencies. And this looks like evidence that language models have also induced that kind of local solution to a long-distance problem. Extremely striking. But the really important thing for the current argument is that this kind of abstract encoding of features seems to hold across constructions. And this is the centerpiece of this new paper I did with Sasha and Kyle called Causal Interventions Reveal Shared Structure Across English Filler Gap Constructions. And what we observe there is that we can do the kind of intervention that I just described, but across different filler gap constructions. In this example, I've taken a filler gap feature from a cleft construction, it is him that the man likes, and placed that in the corresponding place in the model processing I know that the man likes, which is not a filler gap construction. And the observation is that this intervention makes the model think that I know that the man likes is actually an embedded question, I know what the man likes. Really striking evidence that the filler gap feature is abstract enough that it is actually shared across all of these constructions. And of course, that is the culmination of the argument here. As I said before, pseudoclefs are very rare in actual data relative to things like embedded questions and restrictive relative clauses and so forth. But now, if you think about this, here's my very infrequent pseudoclef. It's got the filler gap dependency, but it's getting support, arguably, from all of these other filler gap constructions. And my evidence for that is that I can perform interventions from one clause type into another and achieve the intended effect, showing that there really is something that has been learned that cuts across all of these different constructions. And of course, in the background here, you can imagine that we can do this for all the phenomena of language, constituency, variable binding, wordhood agreement, all of these things are kind of shared substrate for doing lots of hard linguistic things. some robustly tested in the data, and some really only indirectly supported, but nonetheless widely supported in virtue of this interconnectedness. Final thing I want to say before I wrap up, I've been talking about cases where the evidence seems insufficient, not cases where there was no evidence for something. But of course, Kanishka and Kyle took the one step that you need to take and actually tested scenarios where there is no positive supporting evidence. They did this for this unusual English construction, like a beautiful 5 days. This is an unusual construction because it's essentially the only case in English where the indefinite article a can have a plural noun as its complement. You can't have a days, and you can't have a 5 days or a beautiful days, but you can have the construction a beautiful 5 days. It looks completely sui generis. It is really striking that we have knowledge of this construction and that it is so fine-grained, given that it is sparse in our actual experiences with language. But Kyle and Kanishka even took a step further and trained language models that have 0 positive instances of this construction. And those models still prefer the grammatical variants over the ungrammatical counterparts, which strongly suggests that they have learned other constituent facts that come together to kind of loosely entail this attested unusual construction. An extreme case of poverty of stimulus, and nonetheless, we had a kind of correct prediction about the missing phenomenon. A striking case of really pushing the limits of what it means to evaluate indirect evidence and stimulus poverty arguments using large language models. So let me wrap up here by just briefly rehearsing my core conclusions. First, causal interpretability reveals that language models represent deep, abstract connections between different words and constructions. That is already a striking finding. This shows us that the linguistic evidence is richer and more interconnected than we might have thought. If LLMs reliably arrive at a hypothesis alpha given some finite set of experiences D, then alpha was supported by D for a general purpose data-driven learner. Now, if you're a linguist and you want to mount a very refined stimulus poverty argument, you now need to show that alpha was inaccessible given D for human learners. And you can see here in the contrast between 2 and 3 that we really do need to shine a light on the nature of the human learner and posit specific things about those learners. But that's going to be very difficult in virtue of the fact that point 2 here shows we have a general purpose learner that can also achieve our desired outcome. I suspect that arguments of the type in 3, arguments that linguists want to make, can be made, but it will be extremely challenging. And the point that I really want to drive home is that we should not act like we already have an abundance of such successful arguments, because we don't. It's important to try to make them, but it's also important that we not act like we have already made them, because I think that's just distorting of the overall picture that we have of how learners work and how the world works at this point. Thank you very much.